Hi everyone, welcome back to VizWhiz 2. So what I want to do in this screencast is show you how you can use other geoms to visualize the distribution in your data. So what we did last time was use mostly geom point, which gives you plots like this. If we run the last one we got to at the end of the last video, it gives you plots where you're plotting individual data points from raw data to get an idea of the variability or distribution that you've got in your data set. So I think a lot of the power of ggplot is that you can visualize your data without getting very far away from the raw values. Unlike when you're plotting data in Excel or SPSS, where you tend to have already averaged individual participants in individual trials or individual samples from individual beaches. Usually you will have averaged those together before you try and plot something. Whereas in R, it's pretty easy to get an idea of your raw data before you average too much interesting stuff out of it. So let's, we've kind of got our head around geom point and geom quasi-random that allows you to add a little bit of jitter to your points so that they don't line up right on top of each other. What I want to do in this video is show you how to use box plots and violin plots to illustrate similar ideas. So let's add a new heading to our VizWhiz script. We're going to call this boxes and violins, right? So you can see we have our plot beaches data here. Let's make a plot that is similar to what we were looking at last time, but instead of using geom point, let's try geom box plot. So we're going to take the plot beaches data and pipe it into, let's get rid of all the NA values, just hide them. And then we want to call ggplot, setting our aesthetics to be, let's put site on the x-axis and beach bugs on the y-axis. And remember that when we're dealing with components of a ggplot, once you've set the aesthetics, you want to add layers to it rather than piping it into the next step. So we want to add, in this case, a geom box plot instead of points. Let's see what that looks like. What is this telling us? Unexpected end. All right, we'll see if it runs. Seems okay. All right, first thing we want to do is, like before, all of these sites have been all squashed up so we can't read them. So let's add a coordinate flip so that we can read all of those y. We'll flip it around so that the names are on the y-axis so we can actually read them. All right, now I was expecting that to look different. So that looks remarkably like a point plot, not like a box plot at all. And that's because there are way too many values that are right on 0, right? So we have lots of variability, particularly at sites like Little Bay, but the vast majority of values are 0. So let's, often when you have data that is not at all normally distributed like this, you can use log transform to kind of pull it onto a scale that is easier to handle. So remember how when we put this data set together, we actually did that as a mutate, right? So we have right next to the beach bugs variable, we have a log score. So let's change this and do it as log beach bugs instead. Aha, that looks better, right? So boxplot are the box and whiskers plot that you learned at primary school. I think that these are quartiles. I'll put a link to the documentation for box plots just to make sure I've got that right. So I think this might be median and quartiles, and the length of the whiskers. Yeah, I would need to look that up, but I'll put a link. So this is a nice way of illustrating where 75% of the data falls between these two lines, but there are massive outliers as well. All right, so violin plots give you a similar impression of the data, but they represent the distribution in a curvy way rather than in a boxy way. So let's try the same thing, except we will do that as a violin plot instead. So we'll do plot beaters again. And this time we'll get rid of or hide all the NAs. We'll do ggplot, making our aesthetics have, let's switch it up. Let's do, this time we'll do year on the x-axis, and we'll do, again, let's use this log transformed variable. And if we, remembering to add a geom rather than piping a geom, let's do violin, geom violin. All right, so what does that look like? Okay, so this is averaged across all of the sites, but you can see how these violins have really, really long tails. Most of the data is centered around very low values, but each of the years averaged across sites has a very long tail that is caused by those massive outliers. So let's recap a little bit what we were doing last time, combining some dplyr functions and facetting to get a better idea of what's going on here. So how about let's just look at just the days where at each site it was buggier than average, right? So remember how when we were doing mutate, we not only log transformed the data, but we created these logical variables where we ended up with true false values as to whether in buggier site this particular value was greater than the average bug levels for that site. And this one is whether it was greater than the average bug levels across all sites, right? So let's have a look at what this data might look like if we just look at the days that were on average buggier than usual for that site. So what you can do is throw in here a filter function. So if you go filter, and this time we want to filter for buggier and site is equal to true. Okay. So you use this double equals when you want it to match exactly a particular character value. So let's see how that changes. Actually, I will copy this into a new thing. We'll leave this in the usual way and then run filtered for buggier than average for that site equals true. See what that looks like. Does that, ooh, what did I do there? Data must be a data frame. Did I accidentally pass an AES to the data argument? Ah, I think that error actually means I forgot a pipe, right? So you can take the data, pipe it into this NA omit, which hides the NAs, pipe it into a filter, so you're only selecting for buggier than average equals true, and then pipe that into your ggplot. Let's try that again. Ah, all right. So you can see that once we look at just those days where each site was buggier than average, these violins look much skinnier and less bottom heavy. That makes sense. All right. And then actually it's kind of interesting to think about how how the shape of these violins might differ across sites. So what we can do is just add a facet wrap. We'll facet wrap, and when we use facet wrap, we use this tilde sigil to say we want a facet wrap by site. And that's going to give us a by year violin plot separately for each site. Okay, that's interesting. Now we can zoom on that. So you can see how the shape of those distributions is quite different for each year for each site. I wonder what that looks like if we don't look at the buggier than average. Let's just minimize that, and we'll take this out and see what that looks like. A little less interesting. All right, let's put it back in. So we're gonna filter for buggier site equals true. Not forgetting the pipe. And the other thing we can do is color these things as well. So much like when we were coloring the points, if you add color as an aesthetic, we can say let's color by site, and see what that looks like. Now that'll give us the color of the outside of these violins being different. The other thing you can do is use a fill aesthetic. Excuse my loud neighbors. Fill equals site 2. So we'll try that. There we go. So we have both color and fill by site. Alternatively, if you wanted to differentiate between year, you could color and fill by year. There we go. Excellent. All right, so that's how you can use violins and box plots to illustrate the same kind of distribution information that you can get out of plotting raw data points.